Two. Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, What's on the Horizon for Software Supply Chain, brought to you by Ransomware. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, it will be available for on-demand viewing. We will be sending out a link to access the webinar on demand, or you can visit devops.com/webinars, and it will be available for you as well. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab, so let us know your thoughts or just say a quick hello. If you look at the handout section, you'll see that 5 handouts have been provided for you. So feel free to download those and check them out at your leisure. Finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards. So stay tuned to see if you're a winner. Joining me today is Alex Ryback, Director, Product Management at Ransomware. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
All right. Thank you, Julio. And thank you, everybody, for joining. Got a good session today, so I appreciate you spending some time with us. So as Julio mentioned, I'm the Director of Product Management at Ransomware. I also sit on our internal cybersecurity committee. So I've got a perspective both from the open source world, because those are the products that I manage, as well as any cybersecurity issues, both internal and external for our company. So today we'll be talking about what's on the horizon for software supply chain. And we're going to really focus specifically on 4 topics. So first is what is the current state of the supply chain and what we expect to happen in the future. We'll talk about some regulations that are impacting security and software development teams. Talk about some misunderstandings, which is going to be important to know and why they are the case and what you can do about them. And then talk about what you can do to better manage your software supply chain, both from compliance and security perspective. So as Julio mentioned, please go ahead and enter any questions into the Q&A section. And if you have any feedback, go ahead and put that into the chat. So let's get started. So first thing I want to talk about is, why does the supply chain matter? And I've got a couple visuals here to talk about a hardware supply chain and a software supply chain, because they are very similar yet very different, and it's important to understand that. So if you look on the left side of the slide here, we're talking about a hardware supply chain. So this is an image of a Boeing airplane, and you can see there's obviously lots of parts, lots of subassemblies, lots of vendors in the mix, and the vendors come from different countries with different laws, different regulations. And Boeing is ultimately responsible for managing all of these vendors because they are consuming parts from them. So really important for them to, number one, understand where the parts are coming from, understand who is responsible for support and maintenance of the parts, understand what happens if a part is defective, if something happens to the plane, who's to blame, where to go, where to service the part, where to get replacements. The other thing that's really important is that, the plane has a long life cycle, and it is important that these parts are designed for the long haul. If you switch over to the right side, there's a graphic kind of depicting software. So similar situation. On top, you can see a box with several repository logos, and these are essentially vendors that software producers use to help build their products. So you've got folks like Maven and NuGet and Yocto and so forth. And these are repositories that make open source components available. Developers will pick and choose components based on, hopefully, their internal corporate policies. And they will use these components to expedite development of an application. These components will provide common functionality, things that have been developed by a community. And therefore, typically, you would like your developers to focus on core competencies, things that are unique to your organization, your product, and innovation, not really re-implementing constrained functionality. So this is where open source is great, to be able to accelerate development, to be able to rely on a community of developers for mature capabilities, and to be able to incorporate that into your application. So we typically see almost 80% of a modern software application being comprised of open source components, not unlike a Boeing airplane. Much like the airplane, software goes into lots of hardware devices. Some of these devices, like cars and planes, have long life cycles. So it's really important that the open source communities you rely on are also there for the long haul, right? You don't want to necessarily rely on a sole developer in another country because they may not be around in 5 years or 10 years or working in software anymore. So it's important that whatever products your applications go into, you have a reliable supply chain of software that you consume and ultimately ship to your products. And the other thing that's important to note is, well, strangely enough, Boeing really only works on a couple parts of the plane. The rest are all sourced. Right, they build the rear fuselage and they build the fairing to connect the wing to the body and the tail fin. Everything else is developed by other vendors. And if you look at the plane, that's about 20% of the plane that they actually work on. Very similarly, on the open source side, typically a company will really only develop about 20% by lines of code, unique proprietary code. Everything else is lots of different open source and third-party and commercial software being stitched together into a modern application. So lots of analogies there, lots of similarities, and the challenges are the same. You know, what do you do if an issue occurs? Do you fix it? Do you go to your supplier? Do you know where to go? Do you know where in your code these issues arise? So really important to understand your supply chain, where you fit inside of it, whom you take things from, whom you sell things to, and do people then go and resell your software to somebody else? So now you're 2 levels back from the end customer. So again, important to understand this, and we'll come back to this point a little bit later. So today, the way I see things is the software industry's reliance on open source, along with the sharp increase in open source dependencies, and we'll talk about that, and the frequency of newly reported security exploits, we'll talk about that as well, has really set up a perfect storm for supply chain security. So consumption is increasing, the volume of open source is increasing significantly, the number of exploits that are being publicized are increasing as well. So you've got volume going up, you've got security concerns going up, and if you don't have a program in place and controls in place, there are going to be security issues in your applications. So as part of this webinar, we really want to talk about how do you control that, how do you get a handle on that, and what you can do about it. So let's talk about volume. So open source usage continues to grow, and the reason it's growing is there are lots of dependencies out there. So developers leverage open source in their proprietary applications, and they do it to both speed up time to market and to drive innovation. You know, your development team is bounded by your budget. Well, open source communities in many cases are not bounded. There's going to be lots of developers contributing to various projects. So you get the benefit of all of those skill sets by using those components. So it's very attractive. It's, you know, it's things that is kind of the way that software is built today. And there's lots of benefits that arise from using it. But like anything else, you need to have a compliance program to track usage. The other thing to note is people have been using commercial software for years, and there's typically mature processes for managing the ingestion of commercial software. There's going to be a finance team involved. There's a payment to be made for the license, and it's typically tracked in internal systems. Well, open source is different. Developers are able to individually go out and pull things in that really goes around controls that a company may have in place. So it's important to consider open source ingestion as another stream of materials coming into your product, and make sure that you have the appropriate processes to manage it. So a few statistics here in the 2 boxes on the bottom here. So the box in green are statistics from our own audit services team. So Revenera has a software composition analysis audit team that uses our product, Code Insight, to do scanning of our customers' products, either as part of a services engagement or perhaps as part of technical due diligence in an M&A transaction. And we compile stats every year to just kind of track what are we seeing out there, you know, how's the volume increasing, and what is kind of the nature of the things that we find. Likewise, in the purple box, this is coming from GitHub in their 2020 Octoverse report. And this is an analysis of what are people contributing to GitHub, which is the most popular source code repository out there today. So a couple interesting numbers. Number one, on our end, we're seeing around 80% or more of the content in a modern application is comprised of open source. And this is a significant increase. We're seeing on average a couple thousand items per code base that we scan, which is about a 200%, so 3x increase over 2019 to 2020. So we went from about 600 or so items on average to now over 2,000. If you look on the GitHub side, their numbers are a little bit different. So number one, you see there's about 60 million repositories that were created in 2020. And on average, they're seeing about 700 average dependencies or bill of material items in their repositories. And this is the case of open source consuming other open source. So why the difference? Well, the difference is typically the numbers you're seeing on GitHub are from component level automated discovery. So manifest files, monolithic packages, things like that. The 2,000 items that we see on average are a combination of package discovery along with deeper scanning and manual analysis to vet out things like copy paste, other items like images, icons, documents. So it's a more thorough analysis, and thereby we end up creating more items in the bill of material. But irrespective of which numbers you look at, the trends are the same. The numbers are increasing significantly. They're increasing year over year. And open source usage as a percentage of applications continues to increase. So it's definitely something that requires attention. The second thing I want to focus on a little bit here is the security side of it. So this year, much like what we said last year, is a record year in 0 days. There's lots of vulnerabilities being reported. We've got our own internal Security research team that does primary security research, and they have issued more advisories to date than they ever have in past years. And the overall mood is kind of, everyone's at risk of being impacted by malicious actors. So this is not to scare anybody, right? This is not all about, just fear and doubt. This is about there is risk out there. There is appropriate level of risk containment and mitigation strategies that need to be put in place to ensure that your applications are secure. So, the slides will be provided, so I'll let you read through the bullets, but couple of key points on the slide. There are popular vulnerabilities dating back to 2014 and earlier that had nice logos created, websites, fancy names. But we are still today in 2021 seeing vulnerable OpenSSL 7 years after Heartbleed bug was discovered. We're seeing the same thing with Equifax and Apache Struts. There was a SolarWinds hack late last year. Everybody heard about the Colonial Pipeline infrastructure hack. So the point is that even though there are publicized vulnerabilities, even though there are patches available, we're still seeing lots of evidence of patches not being applied. So it's important that your cybersecurity teams are aware of the exploits, are monitoring patch availability, are building a software bill of material of what assets are going into your applications so that when the next vulnerability occurs, you know where you're impacted, where remediation needs to happen, and ensure that the remediation does in fact happen so that you are no longer exploitable for that vulnerability. The other point I wanted to make was that we are now seeing cases where cybercrime is an actual threat to human safety. There were a couple cases, both last year and early this year, where there was a hospital that in Germany that was impacted by a ransomware attack and they had to shut down their services. And it actually impacted patient health because patients had to be rerouted to other hospitals. In Florida, there was an attempt to poison the water supply by hacking the software that controls the amount of chemicals in the water. So luckily there, an individual was able to manually intervene and stop it. But we're now seeing cases where software is impacting hardware and is impacting human safety. And then if you kind of go to the next level, we're seeing a similar thing in the food supply chain, right? It's the exact same thing, right? We're seeing cases where a beef plant earlier this year, back in June, was hacked. There's a ransomware attack. They ended up paying a ransom of $11 million, but the meat supply was impacted for several days, which meant that both meat wasn't being produced as well as whatever was produced ended up spoiling, right? It wasn't able to be distributed to the stores. So this is direct impact again on the food supply. More recently in October, there's another ransomware attack for Ferrera Candy, which is a candy manufacturer out of Chicago area. Makes lots of treats you can see in the picture there. And I personally like lemon heads. I've been unable to buy them. They're not available in stores because the supply chain was interrupted. Stores had to go seek out other sources to source the candy. The candy manufacturer had to go seek out other suppliers to source the materials they need to produce it. And the entire ripple effect ultimately ended up impacting consumers. So it's important to understand that software, although is not really tangible, right? You can't touch it. It is ultimately ending up in businesses. It's ending up in factories. It's ending up in devices, IoT devices, devices that have long run cycles. So it is important to make sure that the software is secure, so that all these hardware and supply chains are in fact safer and safe for humans. Okay. So let's talk about some regulations. So there have been lots of regulations brewing for several years in various sectors, in the food and drug sector through the FDA in the United States. NTIA is working on telco. Health Canada has regulations around healthcare in Canada. The EU's got lots of different regulations around IoT and cybersecurity and cloud products and telco. PCI standards around financial transactions. So what do these standards have in common? At the end of the day, what they're really after is, can you trust the software that is being used in these various industries? And for you to trust it, you need to have, number one, transparency, and number two, a trustworthy process to manage the software. So if you look at these regulations, there's really four common elements. So the first one is to maintain an up-to-date software bill of material. And we will talk about in a subsequent slide what that means specifically. But think of the software bill of material as a list of ingredients in your software application. What are all the packages? What is all the code that did not get created by your team that is part of the application that you are selling to your customers, or providing SDKs or kits for your customers to build applications on top of your kits and your software development kits. So maintain an up-to-date bill of material of all open source third-party software components used in your application. If you don't do this first step, you can't do the other ones because you don't know what ingredients you have in your product. So this is a critically important step. And again, we'll go through details of what that means. The second one is, when you have your bill of material, when you've got all your ingredients, well, you need to identify known security vulnerabilities for these components. There are several vulnerability sources. The National Vulnerability Database managed by NIST is the most popular one, but there are others. And it is important to be able to know any open source vulnerabilities that have been published are linked to what's called a CPE, Common Product Enumeration, or Platform Enumeration. And that directly ties to an open source component of a specific version or range of versions. So once you have your bill of material, once you know what you rely on, you can then correlate the known published vulnerabilities for those assets and then be able to manage the risk according to you. The other thing to really note, and this is number three, critically important, is that open source doesn't age well. Right? Things age out. Things are okay today, and tomorrow a new vulnerability may come in. So monitoring is critical. Not only do you need to know what components you have and what the vulnerabilities look like when you review them, but you need to stay on top of updates and make sure that you understand that as new vulnerabilities come in, things that were benign or things that were perfectly acceptable when they were reviewed may fall out of compliance and may require updates and may require patches or may require replacement. So just like any other part, open source ages, software ages, important to keep up on that and make sure that you're monitoring. And then have a policy, both for what's acceptable, what's not, as well as a patch policy to be able to quickly remediate impacted components and deliver fixes for your products to your customers. Right? So if you look at all these different programs, ultimately they all boil down to these four things. Determine what assets you have, make sure you identify vulnerabilities, keep monitoring it so that things don't age out, and maintain a policy for patching and delivery of fixes. So let's talk about what's happened in the US this year. So in the US, the Biden administration back in May issued an executive order on improving the nation's cybersecurity. And this was not a unique act, right? As we just looked at the previous slides, there's lots of other regulations, but it gave lots of force and lots of power to this new mandate, right? And it helped kind of start setting up a blueprint of a mandate, a process, and a format. So let's go through this in detail. So the executive order that was issued in May of 2021 is going through a process, and we'll talk about that in a few minutes, of refinement, specific definition, and specific guidelines to come out about a year after the order was made, so in May of next year, on what do companies need to do if they do business with the US government. And specifically, how does the US government trust that the software you sell to it and it uses for the benefit of the citizens of the United States is safe? Safe from security vulnerabilities, and therefore safe from infrastructure hacks, ransomware hacks, and so forth. Now, there's lots of other groups joining in, right? It's not just the US government. There's the FDA for healthcare. There's the National Highway Traffic Safety Administration and automotive. You've got NERC on the energy side, and lots of agencies, as I mentioned, in the EU following suit on very similar guidelines. So we fully expect this to go beyond government, to go beyond the United States, and to essentially become a kind of a ubiquitous mandate on, if you are selling software and your software contains third-party content, please have a process to ensure that you understand what's in your product. You demonstrate transparency and kind of the maturity of your process to manage it, and ensure that you are reporting security issues and patching them timely to your customers. So that's the mandate. The process. So OpenChain is an organization that is striving to develop best practices around managing open source compliance. It received ISO certification late last year, and it is now considered the international standard for open source compliance. It does not stipulate how to do things. It talks about what needs to be done and is a checklist on whatever program you choose to follow, whether it is adequate. Right? It is a checklist on the quality of your governance program without any specific recommendations on how to do any given step. It is a great thing to be part of. There's lots of resources available on their website on how to engage, how to get certified, something that we're working on as well at Revenair right now. And this is a great way to for your supply chain partners to have faith that what you're doing is appropriate, is adequate, and is hitting the mark for being a program that guarantees transparency and safety for people using your code. And formats, right? So for this to work, there's got to be formats that are understood by the supplier as well as the buyer. So there's a couple of formats that are kind of leading the way. So a software package data exchange format, SPDX, has been around for about 11 years now. Their version 2.2.1 of the spec received ISO certification just a couple months ago. And it is seen as the leading format for machine readable data across organizations. It is designed to be a specification to allow you to provide your software bill of material in a format that can be read automatically without humans having to be involved. And it is the format that right now is gaining the most adoption. However, it's not the only one. There's also CycloneDX, there's software IDs. So there's a couple of different formats out there. There's lots of tooling available to transform from one format to another. So it's really up to your organization on which one you prefer. They're a little bit different. CycloneDX is more of a top-down kind of component-based structure. SPDX is more of a bottom-up file-based structure. So there's certainly kind of pros and cons to each. But there are now a handful of standards and a handful of common formats that will make it easier for organizations to share data digitally and be able to push the bill of material information throughout the supply chain to all of the partners involved. Okay, so let's talk about, well, what is a software bill of material? Because one of the main things in the executive order is that if you are going to do business with the US government, you will provide a software bill of material of all applications that are delivered to them. So a software bill of material is a formal and queryable record containing details and relationships of various components used in building software. So lots of words there, so let's break it down. Formal and queryable record means there needs to be a standardized format that is machine readable. So we just talked about SPDX and CycloneDX. So there are standards available for that. When we talk about details, details are components, versions, license, and in some cases, vulnerabilities. The idea is that there needs to be a standard definition of what is the element that is part of your application, right? So if we're talking about Apache Struts, well, Apache Struts has a component, has an organization, has a version, has licensing governing its use, and may have associated vulnerabilities. So if you are looking at a software bill of material part, you need that information to understand what you're dealing with. Relationships. Relationships are important because they define provenance. So what is the origin and what is the chain of custody for third-party content? Who developed it? Where did you source it from? If there is a problem with that component, are you going to fix it yourself? Are you going to go back to where you got it? Are you going to go back to the original vendor? How are you going to get remediated, patched version of that component so you can patch your application for your customers? Very important to understand the relationship. Components. So components could be anything. Components can be parts of, they could be open source, they can be proprietary, they can be free or paid. It could be a snippet of code, it could be a file, it could be the Linux kernel with 68,000 files. So a part is as granular as your organization determines they want to manage at, right? So there's a bit of kind of variability there on how deep you want to go in your software bill of material. But essentially, anything that is not written by your organization is a part that is in your application and needs to be accounted for. And then when we talk about software, right? Software could be a function. It could be a module that's reusable. It could be a subcomponent that ends up in multiple applications. It could be an application itself. So depending on what it is that you are hosting or distributing, whether it's an SDK, whether it's a monolithic application, if it's a software subassembly or a subcomponent that makes its way into other applications, each of these elements should have a software bill of material for it, and then together they can come into a kind of an aggregated software bill of material for the application. So you can certainly go to the link there below, ntia.gov/sbom, to get further details on what are the minimum elements of the software bill of material, what's the specification. Lots of great documentation resources there to help you with the process, as well as tooling assistance. Okay, so let's talk a little bit about common misunderstanding and missteps, because it's great to learn from others' mistakes or misinformation. So let's throw a few things out here. So the first one is this ideal goal of getting to zero security vulnerabilities. Don't fall for the trap. Be realistic. It's not going to happen. There will always be vulnerabilities. There will always be new vulnerabilities. The key is to determine what are the top threats to your application for your customers, the way they deploy your product. Your threats will be different from other threats, right? So it is really important to understand how your product works, how it can be exploited, what type of data does it store, is it hosted, is it distributed to your customers, is it sitting behind their firewall? So each of these layers are security information that needs to be assessed. You will not achieve a perfect zero vulnerability state, because if you rely on any third-party content, there will always be new things discovered. So don't try to boil the ocean. Work in a prioritized manner. Understand what your top threats are. Understand the top three. Focus on those. Then the fourth becomes the first, and kind of keep working the process. This is a process. This is a continuous goal to get better. This is not something you're going to go from not doing to becoming clean in a month or in a year. So that should not be the objective. The next one is folks that say that we do pen tests all the time, so we're satisfied with our security posture. Well, it's great that you're doing pen tests. Keep doing them. But there are also blind spots in pen tests, because you need to be doing static analysis of the code you wrote and software composition analysis to manage open source and third-party vulnerabilities. So when we talk about application security, it's always a combination of three things. It's the static analysis on the code you wrote. It is the pen tests on how your program can be exploited when it's running. And some of the issues in the static analysis will manifest themselves at runtime. But it's also running software composition analysis, or SCA tooling, to understand what third-party dependencies you have and which ones are responsible for exploitable areas of your product. So make sure you're doing all three. Make sure you're doing all three continuously. Static code analysis and SCA go well together, because you're scanning the same code typically at the same time. Dynamic or pen testing typically happens later in the dev process once you have an application deployed. But all of them need to be done continuously. You don't want to do this one time before you're ready to release. This needs to be integrated into your build and become a regular part of your product team's culture. The third kind of misunderstanding is we got a cloud solution. We're not part of the software supply chain, so we really don't have a lot of risk. Well, maybe, but you really need to make sure that that is true, that is a complete statement. You may have a cloud application, but do you release SDKs? Do you release kits? Do you release mobile apps? Do you deliver code to your partners that they then use to build plugins or build interfaces on top of your product, or build APIs to interact with your product? If any of these things are true, then not everything is hosted, and it needs to be treated with care. The other thing to really note is typically when you have a hosted application, it is much more open than if you have a distributed product running behind a customer's firewall. So make sure that you are doing the same level of due diligence for your hosted product as you would for anything that is distributed to your customers. And then the kind of the final misunderstanding we're going to talk about is commercial, right? We pay for commercial software. So we buy IBM or Microsoft, Oracle, and our vendor handles security, not our problem. Well, if, number one, do you have contracts with your vendors to not use any externally developed code? Because if you don't, chances are your commercial software has lots of open source inside. If your customers are impacted, they're not going to call Oracle, they're going to call you. So it is your problem. It is on you. You have a commercial contract with your customers or your partners. So you share the responsibility for making sure that your products, regardless of what elements they have in them, are secure. And you need to be on top of this, and you need to treat it as if you wrote all the code. Now, you may not be responsible for fixing certain things. You certainly may go back to your vendors and require patches for issues in their components. But at the end of the day, you're the one selling to your customers. It's on you to make sure that your applications are as secure as they can be. Okay, so let's talk about the software supply chain. So kind of going back to what we showed in the first slide. So when you talk about a software supply chain, it is really important to understand, where do you source things from, right? Do you have partner code? Are you working with partners who help develop modules in your application? Are you leveraging open source projects? 99.9% chance, yes, you are, and probably lots of them. You've got your own code, right? So you got to make sure your own code is secure. Do you have supplier code? Do you have commercial contracts with suppliers to take code from them, put it into your product, right? So you need to really understand, what are all the ingestion points for software into your product, and make sure that they're properly managed. If you further break it down into kind of the impact of the bill of material, well, the bill of material consists of any software parts. So these can be software packages, could be containers, can be build dependencies, but they can also be source code fragments. They could be other binaries that are not managed by Package Manager, multimedia files, copy-pasted code, commercial code. All of these things go into building your product, and you need to determine where the risk is in your company, in your situation, and make sure that you have the proper controls in place. Now, not every product is going to need to handle every one of these diamonds here. So there's kind of this line of demarcation between a basic bill of material that handles all of the kind of monolithic packages, and if you want to go to the next level of depth and start looking at file contents, right? So that, again, lots of variability there. Companies will have different risk tolerances and different level of resources they can put into this. But just understand that as time goes on, there will be an expectation by the field, by customers and by regulations, to vet every single part that could potentially be exploited. And therefore, certainly tooling is required to be able to do that. So let's talk about, what are some topics to follow on this, right? The supply chain security, right, is a pretty hot topic. Lots of things going on in the industry, lots of discussions. So I wanted to kind of break down 3 things that I'm following, both kind of from my cybersecurity committee role internally, as well as being the product manager on an SCA solution, making sure that we're on top of this. So first of all, the executive order. So the executive order, again, was issued back in May. So that was day 0. And there was a kind of monthly, and in some cases, bi-weekly countdown of critical steps to get to a pilot program. So the executive order was issued back in early May. There was input solicited by stakeholders. And by the way, this is all managed by NIST. They're organizing the best practices. They're soliciting feedback from industry partners, and they are going to be delivering a final report that will be part of the pilot program to satisfy the needs of the executive order and the requirements. So they took about a month to solicit input from various stakeholders. Lots of companies submitted papers. Based on that, in June, they published a definition of critical software. So you can click through the links in these slides to get to the details on this. And then in July, the initial guidelines were published for the minimum elements of a software bill of material. So this is where we are today. We're expecting shortly to get the first set of guidelines for enhancing software supply chain security. So ultimately, the executive order will have specific guidelines, and there will be specific things that need to be done. So November is the first draft of what needs to be done. And then every 90 days or so, there will be a revision to the draft with a final one being published in May and a pilot program being launched a year after the executive order. So keep tabs on this. Make sure that you understand how this impacts you, and make sure that you know what industry you play in, what the regulations are for that industry, and if you happen to be selling software to the U.S. government or selling software to customers that ultimately then sell to the U.S. government, you will need to be on top of this and make sure that you comply with whatever is published by NIST. And for every step, there's always feedback being solicited. So this is a very collaborative process, lots of industry feedback. So if you have not engaged, please do so and make sure that you are making your voice heard in the process. The second thing that is important to understand is what is called VEX, the Vulnerability Exploitability Exchange. So this is a topic being discussed as how do you include security information on top of a bill of material? And this is a fairly complicated topic because the bill of material is essentially static. It will not change from release, during the release until the next release of software comes out. So whatever was in your product will remain in your product unless you push a new release out. However, the vulnerability exposures will change all the time. They're highly dynamic. So there's kind of the friction between the static bill of material and the dynamic vulnerability exploitation information. So VEX is essentially a false positive vulnerability disclosure. It is a companion artifact to your bill of material. The details are still being worked on exactly how it will manifest itself. But the idea is when you provide a bill of material and all the parts, the VEX document that sits with it tells consumers of your product if they do a security scan and they find a bunch of vulnerabilities and you've already done this and assessed a lot of them to be false positives, then the information will be provided in the VEX document, right? So you're essentially saying, here's my known issues, here's known false positives. So let's not spend time going back and forth vetting them because we've already done the work and we can explain why these things are false positives as part of our assessment, right? So this is something that will be incorporated into the SPDX format. And this is something that will ultimately just be part of the SBOM requirements when the pilot program gets kicked off next year. So keep tabs on it. There's lots of discussions in various SPDX and executive order and supply, but be mindful. Allow people to have an up-to-date bill of material along with up-to-date security information for the consumers of that. And then the third topic to follow is this concept of a digital bill of materials, right? So right now we're talking about we're going to be sending documents back and forth, but at some point we're going to get to a point where there will be a shared space to just go in view a live bill of material, right? Today we're still producing artifacts and passing them along the supply chain, but in the future there will be a ledger, there will be a common place, right? Digital commons is being explored right now to have a live bill of material for all the software manufacturers. And this is something that we're obviously following and interested in. And this is what will allow you to have the most up-to-date information and kind of the least friction available to share this information with your supply chain partners. Okay, so a couple things here, and this is interesting because there's been some movement now. So Microsoft just a couple of weeks ago kind of raised their hand and put out a blog post on how they are adopting SPDX, so kind of vote of confidence for SPDX, and how they will now start producing or continue to produce software bill of materials for their applications. So we've been working with Microsoft for many years. They have been doing this for a long time. But now there is a public statement as a response to the executive order, what they will specifically be doing, the formats that they will specifically be using, and the timeline in which this will be rolled out and how it will be available for people to download. So kind of a good vote of confidence for SPDX and a major software manufacturer jumping in and publicly stating that this is something they've been doing and they will continue to do per the guidelines. On the other side here, you've also got Cisco kind of standing up with UK regulations and saying that they will use the software bill of material as a way to comply with UK.gov and their cybersecurity rules with the software bill of material as a way to disclose all the assets in their product so that they are compliant with the telecommunications security bill in the UK. So two major software manufacturers, and Cisco, lots of hardware manufacturing as well, kind of raising their hand and saying, we will officially begin doing this, although it's been kind of done behind the scenes for many years. We certainly expect others to weigh in. It'll be interesting to see if people will gravitate towards SPDX, if there will be a split between SPDX and Cyclone DX. So another thing to watch out for is, which standards get adopted, who's adopting which ones. If you happen to be selling into these organizations or using code from either one of them, you likely want to adopt similar standards just to make data sharing easier. But again, there is tooling out there for transforming data from one standard to another. Linux Foundation has lots of tools out there, so you can definitely look those up as a way to make various formats speak to each other. And then finally, let's talk about, well, what should you be doing? So first thing you should be doing, if you're not already doing it, is educate your product teams. It is very difficult for folks on product teams today because they are being burdened with more and more of these compliance tasks. And unless they are educated, and chances are when they were doing their computer science programs in college, this was not part of the curriculum. There was no cybersecurity training. There was no license compliance training. There was no application security training. So these are things that they need to be picking up in their continuing education. So educate your teams. There's lots of training available, lots of free training available. Make this as much of a culture element of your teams as possible. Make sure you have a compliance policy, which includes both legal and security compliance. Make sure your product teams know that it exists. Make sure they know where to find it. Make sure they understand the basic principles of it. Have standard mandated internal training with a refresher every year for things that change. Critically important. There's lots of vendors out there that assist with security training. They've got various hackathons and kind of more competition-based training, so you're not just sitting through a class. So, look those up. Lots of good offerings out there. Definitely invest in educating your teams. Second thing you should be doing is make sure that you are continuously running static dynamic and SCA tools, static dynamic security testing and SCA tools. Each one is an individual layer of discovery and risk mitigation, right? The more you run, the more controls and the more you're going to find that may result in security issues. Integrate it into your development process, integrate it into your build and your code check-in. Try to provide the least amount of friction to the dev teams. They're busy. They've got lots of burden on them, lots of pressure to release early and often. So the more that this can be integrated, become part of the culture, become part of the automated tooling, the easier it will be for them to adopt these tools. Start producing SBOMs. Again, don't boil the ocean. Pick a few products. Agree internally on the depth of the software bill of material. Are you going to deal with automated discovery only? Are you going to invest in more discovery, deeper scanning, more manual analysis? Which formats are you going to use? You're going to stick with SPDX. You're going to do Cyclone DX. You probably also want to provide some sort of human readable bill of material. Don't forget about third-party notices. Don't forget about security disclosures. Right, so agree on what your company wants to do, and this may vary team by team, but ideally it's consistent, to comply with SBOM requirements, and make sure that you consider the supply chain that you're part of as part of the equation, right? Understand what is being demanded of you by your partners, understand what you need to demand of your suppliers to be able to deliver on your obligations downstream. Work towards OpenChain certification. It accomplishes two things. Number one, it's a real good kind of check of your program, right? The certification process is fairly straightforward. There's a bunch of yes/no questions, and there's lots of support and videos and webinars to help you get there. But it is a really good kind of QA of your process and make sure that your process is complete. So it provides transparency and trust to your partners. It also provides immediate legitimacy of your program. So typically, if you can say that you're OpenChain compliant program, that pretty much answers the question of what are you doing, because the OpenChain certification and OpenChain spec outlines all the details in a mature program. And just by being certified, that means that you are following all of the best practices. And then, keep up to date with the executive order and the progress of it. Understand which industries you sell to, or which industries you partner in, which industries your partners and resellers are selling to or work with, to understand which of the guidelines are relevant to you. Make sure you understand the timelines. Things are evolving, and make sure as these requirements are coming out that you are assessing how that impacts your company. If you need to make any changes, if you need to make any process changes or policy changes, to ensure that you are compliant going forward. Okay, so again, wanted to thank you for your time. There's a link to a few resources here. And again, there's resources in the handout section. So we've got a few minutes here, and I'm happy to take any questions.
Yes, we do have questions, but just as a reminder, if you have a question for Alex, you can go head on over to the Q&A tab and submit your questions there. We have a question here. Would NIST establishing a binding supply chain framework mitigate some of the issues around supply chain resiliency?
I mean, it certainly can. So NIST is looking at, several different things as far as what does somebody do as kind of an individual organization selling to the government? What are the best practices around the entire supply chain collaborating? So they certainly are looking at ways to make sure that the entire stream of data as it's making its way through the software supply chain is trustworthy and collecting additional information as it passes through downstream. So yes, for sure it will help.
Excellent. Another question here. How important is an open source review board, and how do you go about starting one?
Okay, so that's a good question. So there's a couple different teams typically found inside organizations to help manage open source. So an open source review board, or an OSRB, is typically responsible for coming up with policies and reviewing inbound requests for open source, which means anytime a developer wants to use an open source package, it needs to go through a vetting process, through some level of discovery, some level of assessment on the dependencies, on the licensing, on the vulnerabilities. Typically, the open source review board is responsible for that. There's also a larger organization, which is called an open source program office, or an OSPO, which is a little more strategic, right? Its goal is typically to operationalize the strategy around open source for your company. Meaning, how do you ingest open source? How do you contribute open source? Are you going to influence open source ecosystems? Do you want to develop your own ecosystems? Do you want to financially support them? If you're Boeing and you're using software from Apache, it is in your best interest to make sure that Apache is around in 20 years because your planes are still in service. So likewise, there's lots of various commercial entities that will support open source communities, and their open source program office will work on the policies and the various steps that they take to do so. So both organizations are typically, they can live anywhere, right? It could be part of legal, it could be part of security. It doesn't really matter where it resides. What matters is that it starts with a policy, right? So that's typically what I would always recommend is, where do you start? Start with a policy. Your policy should talk about things like, when do you need to scan? How often do you scan? Do you need to get proactive permission to use open source, or are you going to just rely on scanning as part of the build? Which licenses are allowed? Which ones are not allowed? What do you need to do to comply with the license obligations? What is your security scanning policy? What do you do about open source vulnerabilities? What are your remediation options? So it is responsible for trying to standardize as much of the processes and roles and responsibilities for who's going to participate. Typically, it'll have representatives from legal or from security. Your CISO may be part of it. You definitely want representation from product teams, because the findings may conflict with your existing product roadmaps. So you're going to have to work these in and give them the appropriate level of priority in your backlog. And you definitely want engineering teams to be represented as well, because they're the ones who are often going to have to do the work. So lots of resources available on both. Definitely something great to invest in if you don't have one already. But I would start by checking with legal. You probably already have some things in play that folks may not be aware of, with at least an open source policy.
Okay, next question. Organizations define SBOM differently. Based on that, how do you move forward with the right SBOM approach?
Yeah, so definitely organizations define them differently. Here's, I guess, a couple of variables, and we talked about a little bit in the presentation. So number one is what formats are you going to use? And you may have more than one. That will typically be dictated by understanding your supply chain demands. What are you receiving from your partners? What are you sending downstream to your customers or resellers, right? If they are demanding an SPDX document from you, then you will likely be producing SPDX documents. You may have to produce both SPDX and CycloneDX. You may want to also produce a human readable bill of material, and you kind of need to agree on what that's going to look like. It can be an Excel spreadsheet, it can be an HTML report, be a PDF, right? Whatever makes sense for you, but it needs to be something that someone can understand. The other variable is how detailed is it? You know, how far are you going to go? Are you going to vet every single line of code in all your products? Are you going to rely on kind of build integrated push button scanning as a phase one? And then over time, you're going to go deeper, look more at the forensic evidence, try to capture things that are not monolithic packages, individual source code, you know, fragments being copied in, things like that. So a lot of it, again, it kind of goes back to your OSPO or open source review board. What is your policy, right? If somebody challenges your process, do you have everything documented? Have people been properly trained? Do you have a process defined that people are following? And it may be that your process is inadequate and needs to be refined over time. But all of these are kind of long-term projects. They will get better as you invest more cycles in them. So definitely take the time to set it up to your level of risk and how much risk you're willing to tolerate, and make sure that you have frequent retrospectives and refinements of the program and how much you're going to invest and do with it.
Excellent. Okay, next question. What does Ransomware see as a result of all the industry change that's happening?
Yeah, another good question. So lots of things, right? Every company will interpret things differently. We at Ransomware, you know, which is part of Flexera, certainly sell to the U.S. government. We sell to defense contractors, so this will definitely impact us. We have been working on setting up an open source program office. We set up a new cybersecurity team. We've hired new people to staff this team along with existing employees. We've redefined all of our internal standard operating processes, our vulnerability management process. We've refined how we react to external security incident reports, set up a response team for that. So we're now working through how we're going to deliver SBOMs for all of our products, you know, this year and into 22. So we're following it just like every other organization is. We're determining what is appropriate for us, what we're willing to do. We're certainly working with our supply chain partners to make sure that we are delivering on what they need from us. The one thing that we're definitely seeing is more and more when we sell our commercial software as part of the RFPs during the pre-sales process, as well as the commercial contracts, open source disclosures are being asked for early and often. And beyond open source disclosures, people are asking us about what are your security practices, what is your security operating procedures, what is your open source governance practice, right? So there's lots more interest in this, not just from supply chain partners, but directly from end customers to make sure that whatever they're buying is trustworthy and that they can rely on our processes to make sure that products are as secure as they can be. So.
Okay, and the last question I see here, are there any specific trends to be aware of heading into 2022?
Yeah, so we talked about it a little bit. Certainly, you know, keep up with executive order updates and what is happening there. You know, the thing I just mentioned, I definitely think there's going to be a trend where more people will demand disclosures from you. So I would certainly expect that. Earlier this year, we looked at some past numbers, and we were seeing close to 25% of our customers are now officially demanding an open source disclosure, whereas before this was typically not asked for. So expect that you will be asked to invest in, you know, OpenChain compliance, because that will give you kind of the requirements on how to set up a program properly to be able to generate these compliance artifacts. We definitely expect there to be, you know, formal guidelines on what you need to do to cross the threshold to be able to sell to the U.S. government. We certainly expect there to be kind of a collaboration and consolidation of all these requirements around the various industry groups. So as long as you comply with this set, it hopefully will work for many different industries. And we definitely do not see any sort of slowdown in open source consumption or open source creation. Lots of projects being created all the time, lots of new ecosystems popping up. So we definitely do not think any of that's going to be slowed down. So we expect the kind of the long dependency tail to get much bigger over time. So invest in tooling, invest in processes, and make sure that you kind of look back and refine and improve these things over time and just make it part of your team's culture.
Excellent. Okay, that's all I'm seeing for questions for now. Just as a reminder that today's webinar has been recorded, so if you missed any or all of the webinar, you will be able to watch it again. We will be sending an email with a link to access the webinar on demand, and you can also find it on devops.com. Just look in the on-demand sections in the webinar page, and it should be there. I did mention that we had 4 $25 Amazon gift card winners, so our first winner today is Kevin S. Congratulations, Kevin. Our second winner is Jose C. Congratulations. Our third winner is Carlos M. Congratulations. And our final winner is Colin M. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your spam folder. Alex, again, thank you very much for putting this program together and taking the time out of your day to present.
Absolutely. Thank you to everybody for joining and spending some time with us. Have a great day.
Of course. Thank you to the audience for their time and engagement. This is Julio Godinez signing off. Until next time, be well.